Hello children, welcome to channel Sube. Children, today I am going to discuss question number 40 from the MCQ part of 2022-23 Physics New Syllabus paper. 6 uniform metal rods AB, BC, BD, CD, CE and DE are connected as shown in the figure. All the rods are identical in length and cross-sectional area. The thermal conductivity of material of rods AB, BC and BD is K1 and that of rods CD, CE and DE is K2. All rods are well lagged and the ends A and E are maintained at temperatures theta 1 and theta 2. Theta 1 is greater than theta 2 in brackets respectively. Which of the following graphs best represents the variation of rate of heat flow in brackets capital Q along the rods AB, BC and CE after steady state has achieved? So they have given that it is at steady state. Children, first of all let us move these graphs to a side so that we get rooms to discuss the question. So children, I am going to use colors. Then we can get this question into our head easily. So they say that these rods are made of same material, that means the thermal conductivity is K1 here, K1 and K1, these three are made of same material. So these are made of some other material whose thermal conductivity is K2. So now easily that idea goes to our head. They have denoted here K2, 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 these three are. So now then what they have said is that this side is at higher temperature. So I draw a flame so that that idea also easily go to our head. Say there is a candle or something like that. Suppose the temperature at this side is 100. Let us take let us use values, then it will be easier to understand. And also let us suppose that this side is at 0 centigrade, because they say theta 2 is less than theta 1. So here I draw some ice cubes to denote the temperature is less. So let us write here the temperature is 0. Suppose the temperature is 0 centigrade at this side. So what they ask is variation of rate of heat flow, capital Q, rate of heat flow, that means dq by dt. We normally write it as Q divided by T. In the thermal conduction equation, K A, you know, theta 2 minus theta 2, theta 1 divided by D is the length of the rod. So this one is the thing that they are asking about, that they have denoted it as Q, as Q. So we have to use this one as Q dash and T dash therefore. So the temperature at this side is greater. So little by little temperature is decreasing from left to right like this, and finally it reaches 0. So suppose the temperatures at these junctions are like this. So there are 3 parts here, therefore I roughly divide the range. There are 100 degrees. So here suppose the temperature is 60, suppose 60, and here the temperature must be less than that, because little by little temperature is decreasing down to this side. So suppose here the temperature is 30, and here finally 0, at this point finally 0. So now suppose the rate of heat flow Q is 50 joules per second, 50 joules per second coming from this rod. So suppose here the rate of heat flow is 50 joules per second. Then what happens at this junction, since the system is steady, what does it mean? This temperature can't change, it never decrease or increase. Why? The rate of heat flowing into this junction must equal to the rate of heat flow flowing out from this junction. Input must be equals to the output. Then this temperature doesn't increase or decrease. So if the heat of rate flow is leaving this junction is lower, suppose incoming rate is 50, outgoing rate is suppose 40, then what happens? Heat is accumulating at this junction, so the temperature must increase. But the system has reached a steady state, so therefore this temperature can't go up or go down. Therefore this 40 must be something equal to this input rate. But there are two branches. Heat is flowing along this line and along this line as well. So therefore, since these two paths are symmetrical, what we have to now think is the both lines are conducting heat. So here along this line it must be 25, and here it must be 25, then altogether 50 is achieved. It is equal to the 50 incoming rate. So now here at this junction, incoming rate is equal to the outgoing rate. Outgoing rate means these both, because both the rods are conducting. Both the rods are conducting. So therefore, since these both paths are identical, we have to divide this incoming rate into 2. So we get 25 and 25 like this. If incoming rate is 50, these two lines must conduct 25 joules per second. So to this junction now 25 is coming, 25 joules per second is coming, and since this temperature must stay constant without increasing or decreasing, because the steady state has been reached, so therefore what is the before that I have to tell you something. Since these paths are symmetrical, we have taken already this temperature at this junction is 30. So this junction also must be 30 because both the paths are identical. So therefore the temperatures must be equal at these junctions. So here at this junction the temperature is 30 and also here 30. So can any heat flow along this rod this way or this way? No, can't, because there must be a temperature difference for heat flowing, but there is no such a difference. Temperatures are equal. So therefore along this rod no heat is flowing, therefore no influence, so we can delete it. It doesn't influence the system, it doesn't contribute to conduct heat this way or that way. So therefore we can delete it. It is useless. So what I was saying, the incoming rate to this junction is 25. So now only one way out, so this line, so it must conduct 25 joules per second. I don't write that all the times because there's no enough room here. So just I write 25. Incoming rate is 25, so outgoing rate must be 25 because this temperature otherwise change means increase or decrease, as I explained earlier. So since steady state has been achieved, so incoming rate must be equal to the outgoing rate. So here also the same thing, incoming rate is 25, so outgoing rate must be 25. So now altogether at this junction 25 plus 50 is there. So now we can plot the graph here. So what I have written is these values are Q. At the beginning I have written like this. So these are Q. Q means rate. Actually this rate means what we write as Q divided by T. They have taken as Q. So however that is the rate they have written as Q without writing the time. So this value is Q. This value is also Q. So let us take Q to y-axis, that means the rate, and to x-axis what they have taken the rods A, B, C, E, A, B, C, E. In all the graphs A, B, C, A, B, C. So therefore let us write A, B, C, E. That means where A? Here A, B, C, E. This is the path they have taken to plot the graph. So along that let us take Q values. This one is A rod, so 50. So here somewhere 50 must be there. Then so this is the graph. Then this rod, B rod at B. So at B junction, so 25. 25. Rod B is conducting 25 is center, 25 up to C. B and in between B and C, the rate of heat flow is 25. That is the idea. Like this and like this. In between B and C. Then in between C and E, what is the rate of heat flow? 25. So again 25. So this is the graph. So now we have to select. Only we have to now select this one. 50, 25. They have not written 50 or 25, but the half is obvious here. If this one is full, this one is half. So this one is the answer. Second one. You understood, I think. let us take this graph to that place. So equal, you see, equal. So the answer is, children, the second one. So you don't have to write any equations, just I have written this equation, but I didn't use it. I wrote this equation because to show you that what they have taken as Q, it is not actually Q according to our knowledge. What we say Q is the total amount of heat, but they have taken Q as the rate. Rate means divided by T. Here rate. So sometimes they use different types of symbols than we normally use in the classroom, because they want to know exactly whether we know this or not. So therefore they use that like that, different types of symbols. So however, now after applying colors to this diagram, easily we can get the idea into our head. Due to symmetric, the heat rate of heat flows must be equal in these both lines, upper and lower lines. So therefore we could remove this rod. So the problem became simpler than the original one. So children, let us now try to do some target questions. Children, here I prepared the target question for you. The first one, target question number 1. So read the question. I have changed the original question. So you can answer this, I think. Just you have to follow the same path that we followed in the previous original question. So pause the video and honestly try to do this without looking at my answer. Now pause the video. So children, since you have paused the video, now I am going to start the discussion. So as previous, you see the symmetry. It is equal both sides, up and down sides along this line. So therefore the heat coming along this, so let us first of all suppose the temperatures are like this as previous. So let us suppose here the temperature is 60 and here the temperature is 30 as previous. So the heat coming along this rod, suppose 50 joules per second. Not joules, 50 joule per second. You can't use plural for units. That is a rule. 50 joule per second. So then, as previous, these temperatures should remain constant because the steady state is reached there. So here suppose the temperature is 50. Then here also it must be 50 because the path is symmetrical. The path up to this level is symmetrical, and also path the heat has to go also is symmetrical. So therefore the temperatures must be equal, and also that temperature is not it is useless. Let us take the temperature at this point. Suppose the temperature is 55 here. then the temperature at here also should be 55 due to symmetrical property. So therefore we can delete this rod. It doesn't flow, it doesn't contribute to flow heat, conduct heat downwards or upwards. Therefore it is useless, because there is no temperature gap along that, across that rod. The temperatures are equal. To heat flow, one side must be greater temperature wise, other side must be smaller. But here the temperatures are equal, so therefore it doesn't contribute to conduct heat. And also the same thing happens to this one. Suppose the temperature is 35 here, and the temperature here also 35 at this junction. So therefore there is no temperature gradient, there is no temperature difference. Therefore this rod is useless. It doesn't conduct heat to any direction. Therefore it is useless. So the simplified form is now like this, as previous. Only we have curved rods, but the principle is same. So here along this line there must be 25 joule per second if the initial rod conducts 50 joule per second. So here also 25 must be there. Both sides are conducting the same rate of heat flow. So here altogether finally 50 is the sum. So let us draw the graph. Let us draw the graph. A, B, C, D, E. A to B, B to C, C to D, D to. So A to B is 50. The rate is 50. A to B until this point. Then B to C, the rate is 25, half. 25. B to C. Then C to D also 25. Because the same the material is different, but the heat flow must be, the rate of heat flow must be equal, because this temperature otherwise doesn't stay constant. But it must stay constant, because the steady state is achieved, is reached. So then C to D is 25, 25. So this line is 25, half of 50, 25. Then from D to E again 50. And then the graph is like this. So which one? Third one. This one is the correct answer. Sometimes you might have chosen this one, but the correct one is, it is obvious. How I explained how it comes. So the third one. So children, I think you understand. I explained everything, taking these numerical examples, so that way it is easier. So you don't have to write any equations here, just using your common knowledge, common sense about the lesson heat, you can do it. So children, let us try to do the next one, next target question number 2. Now this one, let us finish this. Children, here is our next question, target question number 2. So try to solve this problem without looking at my answer, honestly, using your brain. Now pause the video. Since you have paused the video, now I am going to start the discussion. So let us use numerical values. then you can easily understand that. Suppose the temperature is here 100 as previous, here 0. Somewhere here at this junction, suppose 60. At this junction, suppose 30. So the heat coming along this junction per second, suppose 70 joule per second. 70 joule per second. So at this junction and at this junction, between these two junctions, there are 3 rods. All these 3 are conducting heat. So you see, it is obvious that this length is greater than this length. So now let us use the equation for rate of heat flow. Q divided by T equals K A theta 2 minus theta 1 divided by the length. Length means D. Normally we write D. So this length is D. Regarding this rod. So for this, all these 3 rods, 2 curves and 1 straight rod, this temperature difference is same, because 60 minus 30, 60 minus 30, 60 minus 30. So the value is 30. 60 minus 30. So cross-sectional areas are also same. It is mentioned in the question. And K, thermal conductivity, also is same. Only the distance is different. So it is inversely proportional. You see, it is at the denominator. So rate of heat flow is inversely proportional to the length D, or we can write L. So let us compare the lengths. If the radius is R, what is this length? 2 phi r, the circle is 2 phi r. Here, then 2 phi r divided by 2, because half circle, semicircle. So 2 to cancel, phi r. Normally we take phi as 3, no? Then 3 times r. Phi r means 3r. What is the length of this one? R, the diameter, 2 times radius. So 2r. This one is 2r. This one 2r. So this one also again 3r as the above one, 3r. So the ratio must be inversely proportional, because the D is at the denominator. So the shorter rod conducts more heat. The shorter rod conducts more heat due to this D is less than others. So this Q value rises up. So therefore we can now divide this 70 into pieces, and suppose this one conduct 30 joule per second. So this one, so 3 to 2 radius, but here inversely you have to take 3 for this one, you have to take 2 for this one, inversely proportional. So 30 therefore I get, then here 20 joule per second, and this one also conduct 20 joule per second, then 30, 40, 50, 60, 70, 70 is okay. So this is how heat roughly, not exactly, roughly the heat flow, the rate of heat flow is like this, should be like this according to the theory, because the length is greater for these curved rods. So this shorter rod conducts more heat per second, 30 joule per second. So I use the ratio method. I think you can understand. because 2 to 3 ratio, so we have to take 3 to 2 ratio for rate of heat flow, Q. So this the sum gives 70, the sum gives 70, 30, 20 and again 20. Here again 70 joule per second, because this rod alone must conduct all the heat coming per second to this end, otherwise heat will be accumulated here, then the temperature must increase, but it can't be happen because the steady state is reached. So now we have solved this question. So it is obvious that these two rods have the same Q value. That means QA must be equal to Q this one D, QD. So first of all let us select A equals D. So this one correct? Might be correct, first part is correct. So A equals D, this one first part is correct, this one also first part is correct, but here A and D are not equal, therefore they are totally wrong. Now QB is greater than QC. QB is greater than, QB is 30, QC is 20, QB is greater than, not equal, so this one is wrong. It is in this answer they say it is equal, B and C, can't. So B is smaller, B is less than C, so this one also wrong. B is greater than C, correct, B is greater than C, yes, this one is correct. So the answer is third one. So children, I think I explained well so that you can understand it. I think I am successful. So let us try something else now. The answer is third one. Children, when I was searching in the internet, I found this diagram, this picture. This shows this one is a metallic cube. So it is heated at this side, so you can see the temperature denoting using this indicating this red color. So little by little the this one is not lagged, this one the sides are open so that the heat goes to the atmosphere, so it is not lagged. So this side is heated, so the temperature change, the temperature pattern you can see here, the temperatures are there, this one is the coolest, so this corner is the coolest, so we can draw like this the temperatures roughly like this. This side is red color, say 100, and then this one say 80, and this one say 70, like that. The temperature goes like this. The temperature pattern is like this, say 60. So at these corners the temperature is very low. Why? Why that happened? Because the surface area is larger here. The surface area is larger here. At this corner, heat is cooling. Heat is leaving the cube, losing the cube. Heat is losing from this both sides. So therefore, at this corner, the temperature is very low. We can't imagine that if we didn't see this. So therefore keep this in your mind. Sometimes they might give this diagram, just a pattern, they might give a pattern. This one is the correct one, so we can give false patterns for other answers, something like this or this way. Some pattern might give, those are wrong, so this one is the correct one. So keep that also in your mind. Sometimes if they show this diagram picture, they might give next time in the exam. So that is a tip. So children, now I am going to wind up the video. So we did few questions today, target question 1, target question 2, and this one also. So I think you are happy, children. So if you are happy, what you have to do, you have to make me happy too. How you do that? You have to subscribe my channel. If you haven't yet subscribed it, right now do it, otherwise you will forget it. And also share my link among your friends and ask them to subscribe also, because I have only 600 subscribes, I need 1000. You can help me to collect them. And also you can ask your friends and relations to subscribe my channel, because everybody has phones these days. So using those cell phones, you can subscribe my channel and help me to collect 1000 subscribes for my channel. And also press the bell icon, that is helpful for you. And also give likes to this video, then only it will be pushed by the YouTube. So there is the system. So children, help me as the same way as I help you. So children, thank you very much for watching my videos, and thank you very much for subscribing my channel, and thank you very much for sharing my link among your friends, and also thank you very much for liking my videos. So children, so long. See you tomorrow at 6 o'clock in the evening. Goodbye.